Good evening and welcome to Mining Engineering in a Low Carbon World. I'm Kray Luxbacher. I'm the Department Head of Mining and Minerals Engineering, and I'm also the Charles T. Holland Professor of Mining Engineering. It's great to have you with us tonight. What I aim to do tonight is talk to you a bit about what mining engineering is and what the future of mining engineering is in a low carbon world. Following that, I'll talk to you about our curriculum in the department here at Virginia Tech, so you get a sense of what our students actually do day to day, and also what a mining engineer does day to day. Okay, so first I'd like to ask you what you think of when you think of a mining engineer. Unfortunately, when I ask students this, often what they think of is the picture that you see here. A very low tech job, dirty, pickaxes, not many tools to work with. But in fact, this is what we really see when we think of mining engineers at Virginia Tech. On the left here, you see one of our senior students, Kelly. This is her at her internship at a high quality limestone operation with Loas North America. And on the right are some of our departmental researchers who are examining how to fly drones in GPS-denied environments, like underground mines. So what does a low-carbon world look like, first of all? For me, when I think of a low-carbon world and I think of the Paris Climate Agreement, the first things I think about are renewable energy and the switch from fossil fuels to renewable energy. To a lot of people, it seems like, well, if you're moving away from fossil fuels, what's the role of mining engineers in that? But we do have a big role to play, perhaps even bigger than the role we currently play in the world. So when I think about renewable energy, of course, I think about wind turbines, solar panels, and batteries. But also when I think about low carbon world, I think about construction. I think about all the things we need in modern society to transport people and goods and water and the buildings that we live and work in. Because building all of this infrastructure actually releases quite a bit of carbon into the environment. So this is another place where minerals have a role to play in a low carbon world. And this slide is pretty sparse because I'm going to come back to it in a moment. First, I want to talk about some of the challenges that we're facing as we look towards low carbon emissions. Many people have low carbon emissions set by 2030 and others by 2050. So I'm talking in the next 10 to 30 years. First, we hear Elon Musk talking a lot about critical minerals, and particularly lithium and gold, nickel. He's picked up a lithium project in Quebec very recently because he recognizes there's a shortage of lithium, particularly in terms of supply. He also says nickel is our biggest concern for scaling lithium ion cell production. That's why we're shifting to standard range cars to an iron cathode. Plenty of iron and lithium. He's right. There is plenty of iron and plenty of lithium in the world, but not necessarily plenty of mines that are producing lithium. The next one I have here sort of puts a negative connotation to mining, which isn't surprising. That's a lot of what you read in the news. This says the world's biggest island, talking about Greenland, has huge resources of metals known as rare earths used to create compact, super strong magnets, which help power equipment such as wind turbines, electric vehicles, combat aircraft, and weapon systems. The metals are abundant globally, but processing them is difficult and dirty. So much so that the United States, which used to dominate production, surrendered that position to China about 20 years ago. I think it's a shame to see this perspective on mining in the United States. And what I have found about people now is that consumers won't necessarily buy an iPhone where the minerals are mined and produced in places that aren't environmentally responsible and conscious, aren't responsible and conscious about labor either. So as I look to mining in the United States, I actually see it booming in the next 20 to 30 years, as well as in other fully industrialized countries and countries that have strict environmental compliance, like Greenland. And then the last article I have to show here says, last year, the government of Prime Minister Justin Trudeau adopted a Canadian minerals and metals plan aimed at boosting domestic mining. This plan also called for reducing energy use and addressing environmental impacts, as well as increased participation by Indigenous communities. I bolded that sentence because that could be a job description for a modern-day mining engineer. Working with the environment and communities is a critical part of the job, no matter what aspect of mining or commodity you work in these days. Hillman also emphasized that the strategic nature of materials requires cooperation among like-minded allies. And that gets to some of the geopolitical issues that surround mining today, particularly in critical minerals. And then I alluded to construction and infrastructure. Bill Gates recently put out a new book, and in it he talks about cement. Gates considers cement to be a great example of something in need of a desperate cleanup to fight climate change. He says, it's over 6% of worldwide carbon emissions. And yet, we don't have a way of doing it that's clean and doesn't cost dramatically more than twice the price. And this is true. And the reason the price is so high is that creating lime from limestone in order to make cement produces an enormous amount of carbon dioxide emissions into the environment. And again, this is a problem that we need good mining engineers to solve. So I mentioned I'd come back to this slide. And what does a low carbon world look like? So when we talk about wind turbines, solar panels, batteries, and infrastructure, these are just a few of the minerals that we absolutely must have in order to affect these technologies in the next 10 to 30 years. You can see for wind turbines, we've got rare earth elements, copper, aluminum. Batteries, really importantly, aluminum, manganese, lithium, nickel, cobalt, and graphite. Solar panels, arsenic, gallium, tellurium, germanium, indium, cadmium, and selenium. And then when we talk about construction and infrastructure, these are things you don't really think a lot about being scarce or critical. Stone, sand, and gravel, coal and iron needed to make steel. But in fact, a single person in the United States on a per capita basis will consume over 1 million pounds of stone, sand, and gravel over the course of their lifetime due to the infrastructure that's built to support society in countries like the United States. So what are critical minerals? I've just mentioned all of these minerals that play a role in a low carbon world. And all of the ones that I showed you just a moment ago in purple are considered critical minerals. So critical minerals are mineral resources that are essential to the economy and whose supply might be disrupted for any number of reasons. The criticality of a mineral changes with time as supply and society's needs shift. By definition, critical minerals are essential for society. They shift as technology shifts. Demand for critical minerals like rare earth elements has increased in recent years with the spread of high-tech devices for personal and commercial use, such as wind turbines, solar panels, and electronics. Rare earth elements are a critical mineral, but they're just one piece of the critical mineral picture. So rare earth elements include 17 metallic elements. They aren't actually necessarily rare when you look at their abundance in the Earth's crust, but they tend to occur in low concentrations, which makes it very difficult to mine and process them. So in that sense, they are rare because they're difficult to extract. And that's why there's so little mining and processing of these elements in the more industrialized countries, the countries that have more stringent environmental regulations. But now, as we move into a new era, we really do look at mining these minerals in countries like the United States. And we need creative, innovative, and smart mining engineers to make this happen. So, as we look at critical minerals and rare earth elements, just to give you a sense of where they occur in the United States, you can see here their occurrence across several different minerals that are listed in the US. So they're practically everywhere. And this is nowhere near the number of mines that exist in the United States. In fact, there are several thousand mines in the United States. Many of them you would be surprised to find are right under your nose, or your feet for that matter. Particularly in metropolitan areas where people don't think a lot about mining, there's usually a stone, sand, or gravel quarry not far away, staffed by mining engineers, sometimes from Virginia Tech. So I hope I've made a little bit of a case to you about the role that mining plays in a low carbon world. Now I'd like to talk a little bit more generally about what a mining engineer actually does day to day. So mining engineers work across the entire mining cycle. They start with exploration of an ore reserve, and that's working very closely with geoscientists to identify a reserve, to characterize it in 3 dimensions so that they might understand how to access it and where the ore grade is most economically viable. At the same time, during that phase, they'll be working with the community to understand how they can provide added benefit to the community and to gain social license to operate, all the while developing environmental plans and permitting. The next phase is mine design, which is really one of my favorite phases as a mining engineer. And this is designing everything from the processing facilities and other infrastructure on the surface to how you'll access the deposit to what kind of mining method you'll use once you do access the deposit. Next is environmental management, and I've plugged that right into the middle of the cycle, although in fact, environmental management is something that happens throughout the entire cycle, from beginning to end. So as you're working on exploration, you're thinking about how you will manage the environment. Are there endangered species in the area that have to be considered? For instance, all the way through to the end of the mine life, when you start looking at reclaiming the land and putting it back to either its original purpose or another purpose. Next is mine operations. And so this is the most active phase of a mine life. A mine could have a life anywhere from 5 to 100 years. So operations also can span a large continuum. And this is the time when you're actively mining and processing ore, usually close to the site. So you're looking at what your markets are, what grades you're going to access and when, how it will be economically viable, what equipment you're going to use, how many people will you need to hire, and how will you train them. And then next is mineral processing. And these are the people that take the ore you've taken out of the ground and make it into something you can sell. There's a lot of chemical processing or chemical engineering involved in mineral processing, in fact. We sometimes like to say that as mining engineers, we're Jacks and Jills of all trades, in that we incorporate a little bit of every engineering discipline into the very specialized mining cycle. So this all translates into aggregates and steel for infrastructure, base and precious metals for technology and energy, rare earth and critical elements, like I talked about at the beginning of this presentation, for advanced renewable technologies like batteries, industrial minerals with innumerable applications, including agriculture. Consistent long-term engagement with communities is now critical to a successful mining operation, and some of the largest automation projects in the world. When you think about autonomous vehicles, one of the first things that comes to mind should be mining. In fact, when we look at remote sites around the world, some are running fleets of over 100 trucks autonomously from several hundred miles away. Now, a little bit about mining engineering at Virginia Tech and what it's like to be a student here at Virginia Tech. So some elements of our curriculum. Every student who comes to Virginia Tech, including our engineering students, go through our Pathways curriculum, which is our liberal education curriculum. So these are your electives that you choose for yourself based on your interests. All engineers have a very similar math, science, and engineering fundamentals program they go through during the freshman and part of the sophomore year. And then once you get into mining engineering, you'll find that you need a strong geoscience background, and we have several hours throughout our curriculum in geoscience. Applications in mining engineering, which I'll talk about in a moment, some of my favorite classes. We have specialized leadership and management for mining engineering. This includes environmental leadership and working with communities. Then we have multi-year mining engineering design courses, and there's opportunity to personalize your curriculum in mining. So I mentioned that applications in mining engineering are some of my favorite courses, and I've taught the most of these, starting with mine surveying and mapping, which I taught for many years. You can see the picture here on the right are some of our students out in the field practicing their skills in mine surveying and mapping. So they use the typical techniques that you would expect civil engineering students to also take, learning how to use a total station and finding out where you are in 3 dimensions. They also work closely with drones, which are a really critical part of mine surveying and mapping now, and they're used from everything for safety inspections and surface mines to evaluating stockpiles to determine how much material you have. In the junior year, students take mining geomechanics, also called rock mechanics, and in this course, they actually get to break rock samples in large presses We have the largest materials testing machine on campus with a capacity of 1 million pounds load. They take fundamentals and applications in mineral processing. So in this case, they look at scaled ways to take crushed minerals and then pull out the valuable stuff from those crushed minerals. Fluids and thermodynamics for resources. So we give applications in mining engineering for these two fundamental engineering courses. And then the explosives and rock fragmentation, which is always a favorite. Here, students learn about the types of explosives they can apply in various types of underground and surface mines, as well as how to design a blast. And this is everything from the size of your borehole to the spacing of your borehole to exactly how you load a borehole with explosives. And then ventilation engineering, which personally is my favorite course and I've taught for many years. You can imagine a ventilation system in a huge underground mine is quite different than your typical HVAC system in a building. In the senior year, students take mine and water reservoir engineering, mine power systems, and automation. So in that course, we look at basic electrical theory, but we also look at practical aspects applied to mining, like three-phase power and automation. And then environmental management for mining and geoenergy. I mentioned specialized leadership and management for mining engineering. And in these courses, we work very closely with our companies that have our alumni working there and then often hire our students. So in the sophomore year, the first course, a new course, is Leadership for Responsible Mining. This is where students first begin to learn about principles of sustainability and how to engage with the communities that their mines will be operating in. We work closely with a Virginia mining company called Luxstone in this course, and they actually put on a leadership academy for our students. In the third year is Mineral Resource Project Management, which is a favorite with many students and looks at the financial planning aspects of mining projects. And these have huge financial implications. It is not unusual for a large mine to be capitalized at something like $1 billion. In year 4, we look at health and safety systems, how they work together, how to design behavioral safety systems for miners, how to evaluate your safety systems, and resource engineering leadership seminar, where again, we're engaging with companies that we work with and others. So for instance, this year, our students were very interested in labor unions. So we brought in a labor union to talk to them about how and why labor unions work. And I did mention that this involves substantial interaction with the industry. We also have other leadership academies outside of class. For instance, our students 2 years ago flew on private planes to Peoria, Illinois for the Caterpillar Leadership Academy. And then mining engineering design is incorporated throughout our curriculum. We start with Introduction to Mining Engineering, Resource Exploration and Design in the sophomore year. And then we move into much more detailed design in the junior year with underground mine design and a separate class in surface and quarry mine design. By year 4, you formed a group and you've chosen a mine you want to design based on real data. And this usually for students is something that they're very interested in doing when they graduate. So they'll choose underground or surface, and they'll choose a commodity based on their interests. So a little bit more about the department outside of class. We cover contemporary issues in mining, which I've tried to make clear during this presentation. We have very active researchers and opportunity for undergraduate research. On a per faculty member basis, we have one of the largest research portfolios in the college. We have a high percentage of students receiving national and departmental scholarships. The thing about mining engineering is that we don't have supply of mining engineers to meet the demand from industry. So we actually have a very large supply of scholarships for people to get and jobs. This is at the national level as well. The picture that you see of me here in my mask, I'm presenting one of our students, Allie, last week with the national level scholarship that she won. We have 90 to 100% permanent job placement upon graduation, and over 85% of students are placed into summer internships before they graduate. Our average annual starting salary last year was greater than $65,000. And we have an annual career fair just for our department with over 30 employers visiting us annually. So that's the picture that you see in the bottom right. In the bottom left is one of our professors, Dr. Aaron Noble, who runs a very large research program and often has between 10 and 20 undergraduate students doing research for him, along with his graduate students. We also have lots of field trips, which I'll talk about in a moment. Other opportunities that we have for enrichment are our student teams, our student design teams. You'll find that every department in the college has lots of opportunities for design outside of class. Ours are the NASA Big Idea. This year was about dust. The Mars Ice Challenge, which is also sponsored by NASA. And both of these teams are multidisciplinary, so they include mining engineers and students from other departments in the College of Engineering. The Not So Boring Challenge, which is an Elon Musk challenge, looking at how to bore tunnels for high-speed trains. We have 2 design competitions through our professional organization, the SME. One is for non-metal mining, the other is for metal mining. Our students actually travel out west and they're sequestered for 2 days together while they work on this design and compete against other schools. This year we finished 3rd in the country. We have a mine rescue team. This group actually solves problems under a mock rescue attempt or a mock emergency, and they compete with and against industrial teams from companies in the United States. So they learn a lot about how to work with a mine that's under pressure. And that's the students that you see in the top right there. And what they're doing is they're solving a problem. The board that you see is a map board. It has a map of the mine, and they're talking through how to get to where they need to get during this simulated mine emergency. We have a Watford Society. It's named for our very own Dean Bev Watford, who was a mining engineering BS graduate in 1981. And this is looking at diversity and inclusion in our industry. So they put on lots of networking events. They go out to elementary schools and educate kids about mining. We have our Burkhardt Society, which is our SME student chapter of our professional organization. They organize lots of events, including travel to our annual conference, which is usually in the Western United States. And then our mining competition team, which is all for fun, and it actually involves students competing in old-timey mining competitions, like shoveling and jackhammering and that sort of thing. They compete against other schools in the US. The other thing that we have happening soon, which is exciting, and we expect it's a space our teams will use a lot, is the new Holden Hall will be opening. This is our new state-of-the-art building, opening in March 1 year from now. It's going to be over 100,000 square feet of space. And what I'm showing you in the bottom right there is our mock mine and automation facility. So we expect to have scaled robots and student teams working in the mock mine area. And you can see there's a mezzanine above that where students can work on automation and programming. I mentioned field trips. We feel that it's really important that our students get to spend time in the field, both through internships, but also during class with field trips. And we do everything that we can to engage with companies in the field. Mining is a very practical and hands-on discipline. So these are a few pictures of these field trips. Our students have traveled to reclamation sites in Virginia, to underground mines in Virginia, both coal and non-metal mines, or what you see in the middle there. And then, even during the pandemic, we've kept up this tradition of field trips, except they've been virtual. So what you see in the bottom left is our students visiting a salt mine it's a Morton salt mine in Louisiana. And we have one of our alumnuses there in the top right who's touring the students around the mine virtually. That's sort of an overview of mining and the role that we have to play in the future. Now I'm more than happy to answer any questions that you have. I'm also happy to answer questions later on if you can't think of any right now, but you think of some soon. So we have students who aren't sure if they're interested in mining, or maybe their families think this really isn't a great career for my student. So it is not unusual at all if you tell me where you're from and you say, I'm really not sure if this is for me. I'd like to know more about mining. I'd like to see a mine site. We have great relationships with producers in practically every state in the country, and we can find a mine near your home if you want to see a mine up close and personal and talk to a mining engineer. We can certainly help arrange for a tour. Where will I work if I become a mining engineer? Some people don't mind working or living in rural areas, but often people think they have to do that if they're a mining engineer, and that certainly isn't true. In fact, many of our students, like so many at Virginia Tech, come from the Washington, D.C. area, the Richmond area, for instance, and they return there. so that they can work in quarries that are providing the stone for infrastructure in those cities. We have some great videos on our website that show some of our students actually talking about their internship and co-op experiences that you might really enjoy too. One in particular is talking about his co-op experience at Luxstone, and it's a very good, informative video. What's my favorite rock? I just saw that one, sorry. Oh, that's a good question. I think one of my favorites might be diatomaceous earth because it's this really strange rock in that it's super light. It's like lighter than water. So it's like you're picking up a sponge when you pick it up. And it's mined in California. And we actually have a little video. We show some of our recent grads, and they'll do a little 2 minutes on here's what I'm doing now that I've graduated. This is my job. And we have one grad on there, and she picks it up and kind of throws it up in the air to show you that it's light and says, this is what I do now in California. But I think that's sort of a fascinating rock myself. Of course, Hokie Stone's not bad either. And what a lot of people don't know is that Hokie Stone is mined right here in Blacksburg. There's actually a small quarry here in town. We often take our students to tour it, although it's such a small quarry that from a technical standpoint, it's not terribly exciting for a mining engineer, but for a Hokie, it's pretty cool to see where Hokie Stone is mined. I don't know how many of you have visited campus, but this is the stone that's on all of our buildings. It's a dimension stone, limestone, and you can actually see the little blast holes in the stone if you look really carefully at the building. Yes, when you visit campus, you must see that. So as you're walking around the buildings, you'll see there's gray stone everywhere, and then occasionally a black stone that's mixed in. And the black stone actually comes from Midlothian, but all the gray stone comes from Blacksburg. And if you look very closely, you'll see the little drill holes in it where they actually blasted apart. And then it's shaped mostly by hand, actually. I also mentioned that we'll have a new building. I don't know how many of you are visiting campus soon, but our new building is pretty easy to spot. It's got a huge crane outside. It's right in the middle of the engineering quad. And as I said, it will open in 1 year with state-of-the-art laboratories and classrooms, including that mock mine that I mentioned. So we're really very excited about that. Thank you so much for coming, and I hope as you consider mining engineering, you'll reach out if you want to talk to me some more, or if you want to talk to a mining student. I can very easily put you in touch with one to tell you a bit what it's like from the student's perspective. So let me know if you want to talk some more. Good night.